What happens when you quit or lower the carbohydrates?
In the first 3 to 5 days, you'll lose weight, which is great. A drop of insulin in your blood and you stop burning fat. You can train as hard as you like. If you're eating carbs, you're not going to improve your fat burning. There's no fat burning zone. So I got diabetes because I got a long family history. And then although I was running all these miles, I was running to try and maintain my weight. The instant, I reduced the carbs, I lost the weight, and my diabetes is nicely under control now. When you take glucose, you have to understand that if it's more than 5 grams, it's going to overwhelm the blood system and your blood glucose is going to rise. Then you secrete insulin. Ultimately, the insulin stops working properly, and that's when you get insulin resistance.
Professor Noakes, welcome.
Thank you, Rena. It's lovely to be with you. Thank you for having me on your show.
Now, we are told to eat carbohydrates for energy and for optimal hormonal and athletic performance. But what would happen to the body if we quit eating carbohydrates for 30 days? So, Professor Noakes, my first question, do we need to eat carbohydrates if we want to burn fat and improve our health?
Well, if you asked me that question 15 years ago, I was sort of, absolutely, you can't get by without your carbs. 15 years later, I know that that's untrue because of the work that we've done to show that carbohydrates are not essential for human metabolism and certainly not for exercise performance. Of course, this is a great change from what I used to teach and what is taught in all the textbooks and all the lectures given by all the experts around the world. So it's not that I'm going to be able to convince the audience in half an hour that I'm right. All I can say is that we started a research direction 7 years ago, and we set out to disprove ourselves. That's the key. In science, you must disprove yourself. And very few scientists are prepared to do that because it's scientific murder. It's a disaster. It's suicide. If you go against the grain in thinking, your career ends. Fortunately, my career had already ended. I'd retired. I'd been kicked out by my university. I'd been kicked out by my profession. So I had nothing more to lose. And I was approached by an ex-South African living in America. And he said, would you like to do some research with me? And I said, well, let's do something on low-carb diets. So we started simply. We said, let's give these people low-carb diets for 4 to 6 weeks and see if they can run 5 kilometers at the same speed that they ran when they were eating high-carb diets. And guess what? We found they could. So that was the first bit. I mean, we honestly didn't know what the outcome would be. And so many scientists will only do research where they absolutely know what the outcome will be. So we had no clue. So I said, well, let's make it a bit more difficult. Let's have these guys run a mile on the treadmill, and then we'll do 6 times 800 meters repetitions on a separate day. And again, we'll change the diet. And we had no clue what would happen. We assumed that they'd do very poorly, certainly in the interval session, because you run out of carbohydrates very quickly when you're doing interval session. And guess what? Nothing happened. They performed equally well on either diet. And we did one other thing. We measured how much fat they were burning when they were doing the intervals. Now, the textbooks say that when you're going at that pace, which happens to be 86% of their maximum, you can burn 0. They put it right there, 0 fat. We discovered they were burning the highest rates of fat oxidation ever measured in any human anywhere in the world. So we totally debunked the theory. So we published that. And of course, no one took much notice. I mean, this is, but you're not dealing with elite athletes, you're just dealing with recreational athletes. This is nonsense. I mean, the human body is the same. And it's not going to be, just because these guys weren't running marathons in 2 hours, it's not going to mean that they're totally different human species. And then more recently, we did the final experiment, which took us 7 years to get the experimental knowledge and the know-how how to do this experiment. So we had the people eat high carbs or low carb diets, and then we crossed them over. So it's called a randomized controlled trial. And that is the best test. So we had the same 10 people. At one period, they ate a high carb diet, and then they switched over to the high fat diet. And they did it in ways that completely control for everything. So we did that, and then we gave them nothing to drink, no carbohydrates to drink during an exercise that they did for as long as they possibly could. And guess what? There was no difference between performance. It was exactly the same. Now, that proves that what you eat before makes no difference to your performance. How much carbohydrate you have before the exercise makes no difference. But we again broke the rules, because now when you exercise, you're meant to take 120 grams of carbohydrate every hour. That's the latest guidelines. We gave them 10 grams an hour, 1/12 of what the guidelines say. And their performance in both groups went up 20%. And the reason was exactly as we speculated. It's because it protected their blood glucose from falling. So exercise performance is controlled by the brain. And the brain is there to protect you. And the one thing it will not allow to happen is your blood glucose to fall. However, if you're going to exercise for 2 or 3 hours without drinking any carbohydrate, you're likely to run out of carbohydrate, and then your performance falls. And that's been known since 1939. Whenever people say, oh, but we know carbs work, they refer to the 1939 paper. But the 1939 paper showed that it works by preventing your blood glucose falling. They couldn't measure what was going on in the muscles in those. They didn't have the technology. When people developed the technology to measure what was going on in the muscles, they said, oh, see, it's all in the muscles. It's got nothing to do with the bloodstream. And so they took it that way. And why did everyone love that? Because the food industry loved it, because now they could tell you to eat 600 to a kilogram of carbohydrate every day. So if you're cycling the Tour de France, you must eat a kilogram of carbohydrate every day. And if you're running marathons, you must eat 600 grams of carbohydrate every day. And so that was the selling point. And we've disproved that. We've proved that the 600 grams or the kilogram before exercise is immaterial. You need a little bit of carbs during exercise, and that prevents your blood glucose falling, which is the real driver of performance enhancement, is keeping the glucose normal.
Interesting. So you've mentioned about athletes and people that are performing exercise with respect to carbohydrates, that they can perform very well with 0 or low carbohydrates, even 10 grams. Let's shift towards the average person, and not just average, the person maybe that's watching, maybe they're not an athlete. My question for you is that, do you think that you need to have carbohydrates if somebody wants to burn fat?
Yeah, so I'm going to be sacrilegious here. And I've never said this before, because I'm a scientist who believes in religion. So I believe both in creation and in evolution, both of them, because they both make sense. And it's clear that humans were designed to eat fat. And you could say that, well, that we evolved to eat fat, or we designed to eat fat, or we combination. I think it's a combination. But if you go back 4 million years ago, the reason humans became human over the next 3 to 4 million years was because we started eating animals, which were full of fat and full of meat, as you know. And that gave us this huge brain and all the other things, and all the physiological and biomechanical changes that occurred, which allow us to run and exercise, all came because we started eating meat. So our biology is absolutely designed to metabolize fat and use fat as the main fuel. Unfortunately, along came the scientists, and they started being gods. And they said, no, God was wrong and we're right. You must eat carbohydrates. And of course, the food industry loved that. And they supported those scientists who said that. So that's why we've moved from God's foods, which are animals, to humans' foods, which are cereals and grains. And we have a choice. We must choose between the two. And I think the evidence is very clear that humans absolutely are designed to burn fat during exercise. And some of the best evidence comes from Louise Burke, who I don't agree with very much, but she did some really good studies on race walkers who are the elite athletes. And she showed within 5 days, these people who are completely addicted to eating carbs, within 5 days, they became massive fat burners, almost as high as the values that we had measured. And it took 5 days. Now, you cannot explain that if you think humans were designed to burn carbohydrates, Because if they were designed to burn carbohydrates, it would take months to adapt to a high-fat diet to burn fat. And the answer is we live in a state, as you know, of high insulin levels because we're always eating carbohydrates. And one of the main effects of insulin is completely inhibits fat oxidation. It at a drop of insulin in your blood and you stop burning fat. And every time you take carbohydrates before or during exercise, you reduce your fat metabolism and you convert to carbohydrates. And now what they'll never tell you is you do that for a very specific reason, because the basis for human metabolism is to protect your blood glucose level. Everything else comes from that. That's the first focus. So the moment your blood glucose goes up, the alarm bells ring and you secrete insulin, you inhibit fat metabolism, and you try to burn that carbohydrate. And that is uniform, whether you're at rest, exercise, fit, unhealthy, everyone does it. So that's the basis. We humans do very poorly when we eat a lot of carbohydrate because we're not designed for it. And what we try to do is to burn it as quickly as possible. And what the scientists did wrong. So if we put someone who's addicted to carbs and measure their metabolism, the first thing they do is they burn carbohydrates. So you say, you see, carbohydrates are the miracle fuel because they provide the jet fuel for exercise. Nonsense. The body's trying to get rid of the carbohydrates, not to burn them, not to use them as a magic fuel. And again, we did the studies in the 1990s and we completely ignored it because I was fixated on this carbs are good. So one of my students, she studied people at rest. And guess what? Most of them burnt a lot of carbohydrates at rest. So now, 20 years later, I said, but why were they burning so much carbohydrate at rest? Because it's the jet fuel. You want to spare it, save it so you can run faster. Nonsense. You're burning it because you've got to get rid of it. And the quicker you get rid of it, the better you can control your blood glucose level. So the reason why carbohydrate is burnt early on in exercise is because you're trying to get rid of it, not because it's a special super fuel. So I got diabetes because I got a long family history, and so I carry the bad genes. And then, although I was running all these miles, I was running to try and maintain my weight. And of course, the weight was difficult because I was insulin resistant and I was storing fat on a high carbohydrate diet. That instant, I reduced the carbs, I lost the weight, and my diabetes is nicely under control now. So and now we know that diabetes is entirely reversible if you get it early enough and if you get people off high carbohydrate diets. So that's the evidence. And so again, it just shows that we're just not designed to metabolize carbohydrates. So the moment you get off the carbs, you start to burn fat, your insulin drops, and then all the beneficial effects occur, including inflammation. And as far as I understand it, inflammation is largely driven by fat cells, particularly in the visceral organs and the liver. And once they become overfilled, they start to release inflammatory hormones. And that then gives you this generalized inflammation. And it's under-recognized. And just another point, that if you're eating a high carbohydrate diet and you're even a touch insulin resistant, you will have an extra kilogram of weight in your viscera, or maybe 2 kilograms. And people, they look at the runners and they say, oh, but they're thin. No, many of them will have visceral fat. And if you're a world-class athlete, 1 kilogram is the difference between winning and coming second or third. And they don't realize it. They just keep pushing the carbs, and the visceral fat is there, but they don't recognize it. And so they're impairing their performance. So you watch the Tour de France cyclists, remember, these guys are eating 700 grams or more of carbs a day. When they get to the bottom of a hill, they throw their bottles away because they think that those 500 grams is going to be a problem. Well, they're carrying 500 grams in their gut and the intestine because that visceral fat. And the only way to get rid of that is to eat a low-carb diet. The resistance to change is unbelievable in this country. I mean, literally, I was sidelined for promoting this diet. And I went before the Health Professions Council, which is the council that controls what doctors do and say. And they accused me of misinformation, essentially, and bad medical practice by promoting the low-carb diet. And it was as a result of speaking to Parliament, or in Parliament, that happened. And nothing changed. No, individuals have changed, but there's the guidelines are still exactly the same as they always were. So that hasn't happened. I think we're winning on the low carbs and exercise side. That's definitely changing. And I think that more and more athletes are adopting low carbohydrate diets, not just in South Africa, but globally. But they're very scared to talk about it because it gives them an advantage. And they don't want to tell everyone what their advantage is. So until we started doing this work and we got the realization that there are two pools of glucose in the body, and no one has ever acknowledged that. And they are totally differently regulated. So if you talk to the average person involved in the exercise sciences or nutrition, they'll say, no, but the carbs, they all just go the same place. They go here, there. They don't. They are directed differently, and you use them quite differently. So let's talk about the small glucose pool. That's the amount of glucose stored in the liver and in the bloodstream. Now, in the bloodstream, there's exactly 5 grams. 5 grams, which is 1 teaspoon. 1 teaspoon of glucose in the bloodstream. So you've got 5 liters of blood. It contains 5 grams of glucose. Now, when you take your orange, I think you mentioned orange juice, probably that's got maybe 20, 30 grams. So now imagine you've got 30 grams coming into the intestine and being absorbed very rapidly into the bloodstream. But the bloodstream's only got room for 5 grams. So now it says there's a crisis. We've got to get rid of the 20 extra grams. And what it does, it immediately drops it into the liver. So the liver takes it up. And if the liver's already full, it'll turn that into fat, visceral fat inside the liver and elsewhere. And that's where the problems start to arise. Once you start packing on the visceral fat and converting the ingested carbohydrates to fat, that's when you get insulin resistance, type 2 diabetes, etc. So that's the first thing that happens. The second thing that happens is if your muscles haven't got much glycogen, that's the storage of glucose in them, they will also take up some of that glucose from the bloodstream. And my hypothesis is that the muscles store glucose purely to lower your blood glucose level. So they're a dump. What the scientist will tell you is that, the sports scientist, is that glucose in the muscles has a special role. It's what makes you the great athlete, and we've disproved that. So if it's not functioning to make you a great athlete, what's the large glucose store in the muscles doing? And it's obvious. It's just storing the glucose to get it out the way to lower your blood glucose. So to summarize, when you take glucose, you have to understand that if it's more than 5 grams, it's going to overwhelm the blood system. And your blood glucose is going to rise, then you secrete insulin. And insulin has many detrimental effects. And if you become habitually always raising your insulin, ultimately the insulin stops working properly and it can't get the glucose out of the bloodstream. And that's when you get insulin resistance. And as you become more insulin resistant, you hypersecrete insulin. So you always have an elevated insulin. And then that insulin activates a wide range of biological events in the body. And none of them are beneficial. And most of them are harmful. So that's why we talk about insulin resistance as the key driver of chronic disease. Now, the thing about insulin resistance is once you have it like I do, you've got to keep your insulin very, very low, almost between 2 and 4 units. Now, if you go out and measure values in the living population, the values are normally 15 to 30. That's what you'll find, and that's accepted as normal. That's grossly, grossly, grossly abnormal. The highest value you want is about 5. If your insulin is habitually at 5, you'll be healthy. If it's at 6 or 7, I can't tell you you're going to be healthy all your life. So That's how dicey it is. And the only way most of us will get our insulin below 5 is by eating lower than 50 grams of carbs a day. Remember, most people eating a high carbohydrate diet, if they're athletic, will be 500, 600 grams. If they're non-athletic, will be 300 grams. So the body has to cope with at least 300 grams, and not at all the time, but not at one dose, but repeatedly during the day. What happens, in my opinion, is that as soon as you take in more than your 5 grams, then you're going to spike insulin, and then you're going to dump the glucose in your muscles. But if the muscles are already full because you're not exercising, then they're going to convert that glucose largely to fat and store it as fat. And that puts you on the path to insulin resistance. In one of our studies, we had 10 trained athletes, all training 50 miles a week. And when they went on the low carb diet, 30%, 3 of the 10 normalized their blood glucose levels, completely normal. On the carbohydrate diet of 400 grams a day, 3 of them were pre-diabetic. That's 3 out of 10 athletes, not obese, healthy, everything, and they weren't obese, but they were pre-diabetic. And if you go and look at the marathon in Dubai or wherever, and I don't know, I've not watched the Dubai marathon, but I've watched many marathons in Europe and South Africa and Australia, and the majority of runners are carrying a lot of visceral fat. So they are insulin resistant and they're going to be pre-diabetic. And then they're encouraged to take more carbohydrate. So the running is not going to help. It doesn't really get rid of the carbohydrates because you eat the carbs, your insulin's going to be high for a period, and it's just going to promote insulin resistance, as it did in my case. In the first 3 to 5 days, you'll lose weight, which is great. So that's one of the best things about the low carb diet, is get out to a weight scale, and you'll be amazed. In the first day or two, it's largely water. But thereafter, you can get down to, we see 1 kilogram a week easily, weight loss. I've seen one person lose 70 kilograms in 28 weeks. It was 80 kilograms. 80 kilograms in 28 weeks. So that's the best that I've ever seen, but that's absolutely astonishing. So you start to lose weight and you start to feel better. And of course, if you're concerned about your weight, that motivates you. But you get your insulin down and your blood glucose normalizes or starts to normalize. And I did very well on the diet because I must have been diabetic or pre-diabetic. And the moment I went on the diet, my glucose normalized and I started to feel better. So that's the thing. And then your ketones start to rise and they make you feel a lot healthier as well. So the key is you switch off carbohydrate metabolism. You empty your carbohydrate stores and you don't fill them up again. So then you can take the little bit of carbohydrate that you're eating, won't disturb your glucose metabolism, won't cause hyperinsulinemia. And so you keep on losing weight until you reach a stable point, which is what your body wants you to be at. The guy who I told you lost 80 kilograms in 28 weeks, his weight went like this, and then it just stopped. His weight loss just stopped 1 week, and he's stayed the same since then. Yeah, you can probably eat more protein and less carb fat. I think basically the diet works because it's a satiating diet, and that's the key. The reason why we get fat is we overeat carbs and they stimulate appetite, and you're always hungry, as you know. And anyone who's done the diet knows, but that's the key. The key to weight control is to control the carbohydrate and sugar addictions. That's it. It's as simple as that. What causes obesity? Sugar addiction. No one tells you that because I don't know why, but you're not allowed to say that. But that's what's causing obesity. And as soon as you get the sugar out and the carbs and you replace them with healthy fats and healthy proteins, your satiety goes shooting up and you don't eat as many calories. It's not rocket science, but
What happens after 30 days of doing low carb or quitting carbohydrates?
yeah, but then if you're studying exercise performance, it normalizes again. So that would be one of the benefits. But this is not an end. You just keep getting better. I think you would continue to lose weight. You continue to adapt and feel better. But by that time, your metabolism probably isn't changing all that much. The metabolic changes occur very quickly, but the mental adaptations probably take a little bit longer, and the benefits just continue from there, and particularly the weight loss and the losing the fat and losing the inflammation. Those would all be the benefits that you feel.
Is it possible that after 30 days that somebody could be dropping their insulin levels if they have been insulin resistant?
Oh, absolutely, there would be. Yeah, definitely. Your insulin will drop as soon as you cut the carbs. Your insulin will drop. If you take a diabetic and you fast them for 24 hours, their insulin will normalize. So that's how quickly it can happen. And I think it probably takes longer if you're eating some carbs, but it's a very quickly reversible condition. So I shouldn't say, because it's not completely normalized. I'm still insulin resistant, and I absolutely cannot eat any carbs. But I had bad insulin resistance for 30, 40 years. And that's the problem. So for us, we never get rid of the insulin resistance. It's always there, however hard we try. But if you're not pre-diabetic or diabetic, and you stop eating carbs, your insulin will normalize very, very quick. Yeah, that's interesting, because normally we study it for about 4 weeks, and then the studies tend to end. So I think then you normalize, then you just keep going, and hopefully, well, for some people it takes a long time. It actually took me a long time to get my glucose more normalized. So it might have taken me almost a year. Certainly to get over the sugar addiction took a year. So I think that it's an ongoing struggle, but the longer you do it, the easier it becomes. And so I'm thinking that psychologically you continue to adapt to what you're doing. But biologically, most of the changes occur relatively quickly. Yeah, the normal glucose, we'd say, is a fasting. When you wake up, it should be below 5.5, but probably a bit low. 4.5 to 5 would probably be appropriate. Why does it take? Because you remain insulin resistant. And I don't think that the biology of it is all that understood. And I think one of the problems is we've spoken about insulin, but there's another hormone called glucagon, as you know. And insulin and glucagon have to work matched. They have to be absolutely paired. And when you secrete insulin, you must inhibit glucagon, because glucagon does the opposite. It raises the glucose. Conversely, when you secrete glucagon, you must inhibit insulin. For example, if your blood glucose is too low, then you must secrete glucagon, but it's no good having insulin around. And those should be tightly controlled. And they, in fact, talk to each other. The cells of the insulin secreting cells talk to the glucagon secreting cells. And they said, okay, I'm secreting now, you must stop, and vice versa. And I'd be fairly certain that that's distorted. But for some reason, it's not really studied. And so if I tried to find out where's a great study showing that glucagon is elevated in diabetics, it's difficult. There was a period when people spoke about the glucagonogenic cause of diabetes, but it kind of faded because the guy who promoted it, he died, and so his ideas died with him. So it may well be as simple as that your glucagon regulation is also disturbed. And it's the control of insulin and glucagon, and you can't fix that up by just cutting your carbohydrates. You have to do something more. And if there was a glucagon blocker, something could block the action of glucagon, then I think you'd find diabetes would be much easier, much better controlled.
Can you explain what is metabolic flexibility?
Okay, so metabolic flexibility is distorted. If you read the sports literature, it said if you're burning carbs, you're metabolically flexible. That's nonsense, because you're inhibiting fats. And fats is the real fuel, because it's got so much more energy, and we carry it in our bodies. We don't have to eat it all the time. Once you go out and run, you can burn fat, and it can do very well, and you don't have to carry stuff with you, etc. So metabolic flexibility, in my way, is burning fat, being able to burn fat, and that you get because you lower your insulin.
How many carbs we should eat, because it's based on metabolic flexibility. So how many carbs then should people eat?
Okay, it begins with your mother during her pregnancy. That's when it begins. Because if she's a high carb eater, you'll be your metabolism will be damaged and it'll be more carbohydrate dependent from the day you're born. And then what do you get? You get raised on these purees, which are just sugar and carbs and complete rubbish. Whereas in the past, we were raised on animal produce when there weren't these processed foods. I fortunately grew up in Zimbabwe before ultra-processed foods arrived, and we just got the food from the farms, and my mother was a great one for meat. So she raised me on meat, and I was very fortunate for that reason. So that's when it starts. So if your mother ate carbohydrates and you were raised on a high carbohydrate baby foods, you're going to be more carbohydrate dependent and more insulin resistant from the word go. And you need to get down to 50 grams of carbs as soon as you possibly can. It's another interesting thing that I just went back to my old school for a bit and I looked at the kids, and the kids' faces are different than our faces were. I don't have a perfect face because I must have had some carbs. But if you look at the Native American Indians, they had these beautiful faces, big, round faces, absolutely monumental faces. And that was from eating buffaloes, just living on buffalo. And the faces become more distorted and smaller with time. And that's the marker that where children are being raised on cereals and grains, not on meat. And it's becoming more and more obvious. The best advice you can get is to tell families to start eating real foods, animal foods, from as young an age as possible. And then we won't have to have this discussion. Because what you're asking me is for people who are already sick, like myself. And we're the ones who then have to worry about how much carbohydrate we're eating. So I would say that for most people, if you were to eat 150 grams from the day you were born, and well, not less, obviously, with the day you're born, but if you were to build up to 150 grams carbs a day, that'd be fine. You'd probably live your life without any major problems. Yeah, once you become diabetic, you have to go as low as possible. That's it. Well, sorry, let me rephrase that. I think you can judge from your glycated hemoglobin value, the HbA1c, which tells you what your average glucose is. Once it goes above 5.5, you will develop diabetes. If you start at 4.5, you get to 5.5, your trajectory is diabetes. And we normally say 5.5 is fine. It's not. That's pre-diabetic, and you want to start acting then. What happens to most of us, like we get over 6s and over 6.5, and then we diagnose, and then we've got to go down to 25 or 50 grams. But I would guess if you caught it at 5.7, you could probably get away with 150 grams of carbohydrate, and you could, again, normalize. So I think that would be the better advice, is have your HbA1c measured and see what it is, and your insulin as well, your fasting insulin. And if that's elevated and your HbA1c is above 5.5, then you've got to start restricting. And I think it's for people to decide what they can cope with, knowing that less is better. And if you can get down to 50 or 25 grams, that's going to give you the best result in the long term.
And what is the threshold that you want it to be considered optimal and healthy?
Yeah, now you're pushing me because, the textbooks would say anything below 5.5 is normal, but of course it depends on age. If you're 5.5 and you're 90 years old, then of course that's great. But if you're 5.5 and you're 20, then that's not great. So I think there's an age factor there. And if you're eating carbs, your HbA1c is likely to rise continually. So that you have to understand that. And therefore you must decide at what age are you going to have to cut back. And once you go over 5.5, now you must start reducing.
Okay, well, I am 4.8 and I'm 41 years old and I follow a zero carb diet. So that's pretty good.
That's perfect, yeah. I don't think you're going to have any trouble in your life. You'll be fine.
Why is a high-fat diet optimal for human health?
Because, as we said, that's what God created us to eat. And humans created us to eat something else, and that's I like to make it a religious thing now. 'Cause
That's going to be very controversial because when we talk about religious or evolution, people have different perspectives. So we are meant to be eating a high fat diet. Can we talk about fat adaptation and what that means?
yeah, fat adaptation is purely that you can burn fat easily, and that's kind of the metabolic flexibility. And so your muscles have no problem in burning fat to provide all the energy they need. That's how we recognize fat adaptation. And the key is it's a low insulin. You're burning fats and your ketone levels are elevated, and you're using ketone as a fuel to substitute for glucose. So those would be the main features.
As Professor Noakes mentions, fat adaptation occurs when you burn fat for energy. And a really easy way to do this is to simply drop the carbs or go zero carb, also known as the carnivore diet. And when you go zero carb, it is the ultimate low insulin state. You see, with a zero carb or a carnivore diet, I have seen hundreds of people drop weight like 50 pounds, 100 pounds, 200 pounds, while also reversing chronic health conditions, things like heart failure, thyroid issues, even diabetes. And I experienced this myself when I went carnivore 5 years ago. And what I found helped me and my community stay on track was medical support through our team of carnivore doctors. And that is why I created a private carnivore community completely off social media called Go Carnivore. You see, I had the same questions as you. What about my cholesterol? How much protein and fat should I be eating? And how long will it take me to fix my health condition? And that is why I have carnivore doctors that join us every single week to help answer your medical questions and help you get the best results. Is there a certain percentage of fat that you need to eat versus protein to become fat adapted?
No, it's all carbs. You have to get the carbs down. That's the key. Yeah. So it's not the fat that you're eating, it's what you're replacing by eating fat that allows you to become fat adapted. So it's the carbs and the insulin prevent you from becoming fat adapted. And the instant you get your fasting insulin below 5, you start burning more fat.
Okay. And then when it comes to being fat adapted, and then you said that we need to get our ketone numbers higher. So you need to be in ketosis. Now, is there a number that we need to achieve to be in ketosis?
Yeah, that's a good question, because what happens is you become quite ketotic when you adapt this diet. And then you adapt and you start to burn the ketones, so your blood ketone levels drop. And so people get very frustrated. They say, I'm eating this low carb diet and my ketones are only zero point 0.2 or zero point 0.3. And they used to be 0.6. And that was because you weren't using them. Now you're using them as a fuel, and that brings them down. So if you're keto adapted, you could have a ketones of 0.2, 0.3. It's not evidence that it's going to be 1 or 2. That you could get to values of 1 to 2 if you go and do a lot of exercise and don't eat, and so you fast, and then you can get ketone levels of 2 or 3. But just living normally on a low carb diet, your ketones will generally be 0.2, 0.3, or somewhere about there. But that doesn't mean you're not fat adapted. You are fat adapted. It's just that the ketones aren't as high as they were when you started.
If you're fat adapted and in ketosis, if that number is reading low?
Okay, well, you would know because you aren't eating carbs. And that will tell you that you're in ketosis. Or sorry, that you're fat adapted. Yeah, so you have to burn something. If you're not eating carbs, you have to be burning something else, so it'll be fat. So you're looking for confirmation of something that doesn't need to be confirmed. If you're eating few carbs, you're not burning carbs, you're burning fat. So and you can't fake that one. So if you know that you're eating 400 grams of carbs, you're not going to be in ketosis. Whereas if you're eating 25 grams and your ketones are low, you're still burning fat, because where else, this is the answer, from where else would that energy be coming? It's as simple as that. If you're only eating 25 grams, that's going to give you about 10 minutes of exercise. That's all.
So, because there's two types of main fuels that the body can use, ketones and glucose. Is that correct? So, in the absence of glucose,
That's for the brain. The brain can use ketones and glucose. The muscles use free fatty acids, which are coming from fat tissue or from inside the muscle themselves. But so this glucose and fats, and if you're not burning glucose at a high rate, you have to be burning fats. So that's the way to know if you're fat adapted is you're able to exercise normally and you're not taking in carbs, then you're fat adapted.
Okay, makes sense because people always have that question. I want to ask if you do a high fat diet relating to cholesterol and LDL, and if that increases, is that a concern for athletes and also for people that are just doing the diet?
Yeah, that's a great question, you see, because the whole theory that LDL cholesterol causes heart disease is based on associational studies, which mean nothing. So in other words, they looked at populations and they found those with high cholesterols were having high fat diets. And that was explained why they had heart disease. And that's nonsensical science. When they went and tried to prove it by doing randomized control trials in which they changed the diet, no study has ever shown that reducing your fat intake and lowering your cholesterol improves your outcome. So what they did, they short-circuited that, said, no, well, okay, we'll just forget about that, we'll hide it. And I wrote an article about that because I looked at the biggest study, which they invested $700 million into this study called the Women's Health Initiative. And they showed, and they tried to hide, and I exposed it, they tried to hide the fact that the women who started the trial with heart disease, so they're the ones who are most sensitive to a diet, because if the diet's wrong, they're the first ones who will show the problem because they've already got the problem. Their risk after 13 years was 65% increased risk that they would have. There was great increased risk that they would have more heart disease when they ate this fabulous low-fat diet. So that's one of but no one talks about it because you're not allowed to talk about it. So what they did, then they said, oh, well, you see, the statins lower your cholesterol and prevent heart disease. They have almost zero effect. About 1 in 100 people benefit from taking a statin. And that's the only evidence that lowering your cholesterol might have a benefit. But everyone who has heart disease, they don't just take a statin. They take an antihypertensive drug. They treat their diabetes. They take more exercise. They lower their stress. I don't know, but can't be any of those things. It's the fact that your cholesterol's come down with this drug. So the science is appalling. So it is true that cholesterol can go up quite high, but there's no evidence that changing that makes any difference. In my view, the evidence that cholesterol is the problem is nonsense. We have, and what frustrates me is that because they said it's cholesterol and they said, you see, we only have to have one treatment, statins. Statins will cure everything. So guess what? For the last 40 years, no one studied anything else. They've not been allowed to, and has not been funded. So now people will finally realize that statins make no difference. And then they said, but then something must make a difference, surely. And they said, well, we've never studied it because we weren't allowed to study it. So that's the tragedy. And in my opinion, cholesterol's got nothing to do with it. It's an inflammatory disease. And diabetes is the real killer. Diabetes is what destroys arteries. And so you must treat your diabetes if you want to prevent progression of the disease. The tragedy is that the diet that prevents diabetes raises your cholesterol. So then it's a no-no. You're not allowed to do that.